Good afternoon, we are Dream Team from TUT001. Our today's topic is foundation system in Hong Kong. This is our content page. For the introduction, there are some common foundation types being widely used in Hong Kong, such as pile foundations, ref foundation, pad foundation, and strip foundation. The engineers should go through the depth study and calculation process before the construction. The design principle of foundation is to achieve the structural load transfer to the soil layer and minimize the movement and settlements. In this presentation, we will summarize the function of different type of foundation system and to detail research, including the design parameters, components, quality control method, and case studies. For the specification of foundation types, the foundation are categorized as shallows and deeps. Shallow foundation in Hong Kong is based on an artificial embedded depth of 3 meters. The deep foundation in Hong Kong is usually conducted with piles that are placed into the soil by driving in a hole and create the subsoil by drilling and excavation. The structural load to the soil level below the shallow foundation. For the pile foundation, which are a type of deep foundation, it is usually to transmit the load from large structure into harder, better density, fewer flexible and strengther soil or bedrock at deep. Pile foundation raising the overall effective size of a foundation and absorbing the horizontal stress. The pile foundation must be multiplied plans such as calculate the soil due to the bear a lot of weight and not overburden the bearing capacity. Each pile has an effective area on the soil. It surrounds to position the piles too far apart and fairly distribute the weight. The shallow foundation are often less expensive than deep foundation. It frequently employed to support the structure in the area which suitable strong surface materials. And for the pad foundation, it is one of the shallow foundation. Typically separate the rectangular, square, or circle slab installed bench reinforced concrete columns. It usually location where the soil has high carrying capacity and designed by measuring the foot slab to fulfill the geological criteria. The pad foundation also providing a sufficient width and reinforcement to meet the construction needed, and the preparation of pad foundation should not be too tiny to include the sufficient settling or soil load carrying capacity collapse. The strip foundation is also a shallow foundation, using to give a consistent flat strip of supporting a longitudinal construction, such as wall or a centrally located set of columns, used on a wide range of subsoils. It is best suitable to soil with a high carrying capacity. Strip foundation usually conduct with the lightweight building stress, where concrete structure strip foundation may be employed to have an appropriate dip on the soil to prevent the force damage. The depth of strip foundation is usually equal to or larger than the total wall size. The thickness is typically 3 times the supporting wall size. Now I will pass the time to my groupmate to talk about next part. Thank you.
Here comes the design parameters of foundation system. By considering sustainability and safety, an eligible foundation is expected to resist the dead, imposed and wind loads of the building while not causing any impairment on stability or immoderate movement towards the building, nearby mansion, street, land, slope, or any other surfaces. Basically, the allowable capacity is strictly standardized. For instance, an increase by 25% of capacity is acceptable when it is only in view of the wind effect. Here are the general procedure of designing the foundation system. Briefly speaking, a site visit should be conducted before coming up the actual design so as to ensure the suitability and the feasibility of it. For the purpose of obtaining the most appropriate foundation design, several methods should be used, such as the method shown in the screen. In fact, other methods could also be adopted to measure the allowable capacity for friction or bond of rocks and soil and bearing. Different types of land demands different design requirement. First, for reclaimed land, here is the general design rules for reclaimed land. For example, the slabs located on the lowest floor are not allowed to be designed as on-grade slab. Indeed, for land which was reclaimed a long time ago, substantial consolidation might be occurring. Special treatment should be made. For example, owing to the loss of consolidation assessment, the years required after reclamation need to be achieved at 95% degree of consolidation for marine claim. Thickness age of a season can be measured as follows. Here are some specific design rules for design in marine structures, which mainly aiming at transferring loading from the structural design to the subsoil. Hence, particular rules for designated area in the designing stage. A comprehensive ground investigation is required to distinguish all potential and antagonistic geological features. Lastly, for sloping ground, once the foundation has accidentally bestowed additional loads towards the slope, retaining wall, or groundwater regime, tracking should be done for the affected features as a component of foundation design.
Next, I'll briefly introduce the main components of foundation. The sketching on the screen is clearly shows different parts of foundation, and let me explain more. Firstly, on the bottom, we have footing. Footing is formed by filling the ground with concrete from excavated trenches, and it extends along the entire perimeter of the structure. It supports the foundation because it can spread the load. Then is the force lump, where it's placed on the footing. It is usually made of concrete and steel reinforcement. It forms the floor of the basements to resist pressure. Last but not least, foundation wall is the most important component of foundation. The foundation wall is the soil wall attached to the footing and rising to the ground level at the point where the ground is the highest under the building. It provides support to the entire building structure. That's why it's so important to plan and build carefully. If it is built incorrectly, a movement can cause crush and the settlement of the structure may collapse.
Right now, I'm going to provide case studies of the Imperial Cullinan and the International Commerce Center, where both sites are located within the West Kowloon Reclamation Land as inscribed in the figure. The Imperial Cullinan represents the conventional deep foundation implemented in Hong Kong, while the ICC represents the innovative foundation design implemented in Hong Kong. The construction of the Imperial Cullinan commenced in 2007. The depth of the grade 3 or better bedrock of the site has been investigated to be ranged from 25 meters at the east and 85 meters at the west. Furthermore, there are direct connections between the groundwater and sea level, where the tidal range varies from 2.5 meters to 3.5 meters. Regarding to the ground condition and the economical concern brought by the price fluctuation of steel during the time, the developers adopted the large diameter and bearing bulb house foundation with a semi-top-down basement construction method, either with rock socket or not. The foundation of the luxury residential tower has implemented a total of 117 numbers of large diameter and bearing bulb house from 1.8 meters to 3.0 meters for the support of the vertical and lateral loads from the building tower and podium structure. In preference, the cutoff levels within the tower zone were elevated to high altitudes, which was the unique features of the house. It has enabled the power cap to be built early and begin the tower construction with the absence of steel stanchions. ICC is the tallest building in Hong Kong, which is located above the major fault zone, comprised with diverse bedrock profiles. Since the site has been found that the adequate power socket of the bedrock wall foundation exceed 100 meters depth, it would be difficult and time-consuming, also unviable and expensive for developers to construct a conventional foundation methodology, namely large diameter bulb house. Therefore, the developers undergoes investigation and researches and adopted the method called shaft-gritted friction buried piles. The shaft gritting for barrettes is beneficial to boost load carrying capacity with the aid of cyclic overdam, which further enhance the stability of foundation pit excavation due to the automatically maintained compression. The foundation framework comprises of the 241 rectangular shaft-gritted barrettes that were bored to a depth of 70 meters on average. Each barrette was equipped with 8 reservation group house, while 2 are reserved for the blockage events. After the barrets were cracked by pouring high-pressure wet water through the grid pipelines, the grid was pumped under pressure and in every meter's rise via the crack path around the barrets once the reinforced concrete had reached 21-day strength. The presence of an additional shaft ground interface boosts the barret's frictional capability. Each barret can handle a load of 40,000 kilonewtons.
For quality control, according to BO, during each construction project, the EP, RSE, and RJE are responsible for supervising the quality of superstructure. Meanwhile, RSE has the duties to offer supervision continuously and to assure the building works by following the supervision plan strictly. Indeed, some technical tests are performed by the professional to determine the quality of the foundation system in terms of the depth and integrity of it. Take the quality control for deep foundation as an example. There are 3 tests are used to conduct the measures of safety, such as dynamic load testing, pile integrity testing, and cross-hole testing. For the pile integrity testing, there are mountains of advantages, such as applicable to all approaches piles and cost efficient. However, every cloud has a silver lining and still owns some limitations. For example, it is not applicable to piles that owns plenty of cross sections and cannot be carried out over the pile caps.
The second common pile test in Hong Kong is cross-horizontal locking, CSL. This method is to ensure the standard solidity of the builder shafts and the other concrete piles. For the advantages of CSL, which include relatively simple interpretations when a major defect is present, and there is no limitation of pile length, and it is not sensitive to the soil type. The trunk also supports 2D and 3D tomography. For the disadvantages, access tubes must be classed during the shaft construction. It can only access the concrete between the access tube. Some factors, like uncrafted concrete, may affect the result. Lastly, if the results are complicated, evaluations require experience and engineer judgment. Due to the time limit, we cannot detail other pile tests. But in short, each method has its pros and cons in different conditions. By using the pile test, the quality of the foundation systems can be determined effectively.
In summary, we have introduced the specification of common deep and shallow foundation types implemented in Hong Kong, the corresponding design parameters, namely the general design procedures, and the regulations in accordance with the unique geological topography in Hong Kong that most built land is reclaimed, has also been discussed. From the case study of the Imperial Cullinan and the ICC have shown and represent that the common usage of the deep foundation in order to fulfill the load-bearing needs for high-rise building. However, sometimes due to the land restriction in Hong Kong, there are significant influence that innovation in foundation design is required to be capable of the constructing load-bearable megastructures in this highly dense city. Last but not least, we introduced the BRT and the CSL, two typical assessment of quality control for foundation system. That's all for our presentation. Thank you.